Every new telescope put up in space has always found something they didn't expect, something new.
The James Webb Space Telescope is the biggest, most complex telescope that NASA has ever launched into space.
Telescopes are time machines. Webb will push us back into the realm of the very first stars and galaxies in the universe.
The Webb telescope is designed to see as far back in time as we can possibly see luminous objects, when the universe was maybe 100 million years old.
We have a suite of very powerful instruments to study the atmospheres of planets. Webb will be very helpful to us in the search for life in the future.
Up until Hubble flew, we were using telescopes on the ground, and they couldn't see very far.
T-minus 6, 5, 4, 3, 2, 1, and liftoff of the Hubble Space Telescope, our window on the universe.
When Hubble flew, we knew that it was going to be able to reach out further into the universe, but we didn't really have any idea what was out there. The Hubble Deep Field image was a discovery image of the 90s. What was unique about this was the idea of spending days and days of valuable Hubble time staring at a tiny spot in the sky where there was nothing. When we did a deep image like this, astronomers suddenly saw that there was a richness of galaxies in there, thousands and thousands of galaxies we'd never seen before. Basically a history of the whole universe in one image. The universe is 13,800 million years old. Light travels very rapidly, but the distances are so huge.
Hubble can see in the visible and the ultraviolet with a little schmidge in the infrared. But the things that we want to see now, the first stars that turned on in the universe, the first galaxies, they were probably very bright objects that emitted a lot of ultraviolet light. But that ultraviolet light, with a very short wavelength, as it traverses through a universe that's been expanding for about 13.5 billion years, gets stretched out. So that by the time it reaches us, it's no longer ultraviolet, it's infrared.
After they had the Hubble Deep Field, they said, we can't see far enough. So we need a bigger telescope that's more sensitive and that can look at longer infrared wavelengths so that we can see the more distant universe.
About 13.7 billion years ago, there were no stars in the universe. There was just gas and dark matter. We'd gone through 200 million years of dark ages. Suddenly, the first stars and galaxies would start popping up all over the place. Cosmic sunrise. And so that's what JWST is for, mapping the first billion years of galaxy formation and growth in the universe.
The Webb telescope is the first general-purpose, powerful infrared telescope we've ever had. It opens up what I call the infrared treasure chest. If you were a bumblebee at the distance of the moon away from the telescope, we would be able to pick up the heat that you send out. Infrared is special for astronomers because cooler objects that cannot emit visible light are able to emit infrared.
When we look at the universe, you see there's lots of sort of dusty, dark areas. But one of the great things about the infrared is light can travel through the dust. The dust becomes almost transparent. So if we're trying to see how stars and planets form in their early times, the infrared is the place to be.
If you want to see dim stars, you don't stay in the city, you go out to the country, right? You get away from the lights. We want to see the dimmest galaxies there are to see. Well, the Earth is pretty bright in the infrared, so you want to get away from the Earth, you want to get away from the moon.
Webb needed to be far away from Earth, and it needed to be very cold if it's going to work in the infrared. So if you cool the whole telescope down near the temperature of space, then you can see out with incredible clarity over the first billion years of the universe.
So we're going to a point called the Sun-Earth L2 point. It's 1 million miles away from the Earth on the opposite side of the Sun. And it's a place where the gravity of the Sun and the gravity of the Earth combine to make a relatively stable point that follows the Earth around the Sun every 365 days. So if we go out there and we put up a sun shield, a big umbrella, from that location we can block out the Sun, the Earth, and the Moon at the same time. This is obviously no ordinary umbrella. The 5 individual layers are made of a almost plastic-like material called kapton. 200,000 watts of solar radiation strikes the hot side, and the sun shield will only allow about 0.02 watts to get through. If it were suntan lotion, it would have a solar protection factor of about 10 million. So the telescope and the instruments are exposed to cold space.
The Webb telescope is the most difficult scientific project we've ever undertaken. It's got to unfold itself in space.
James Webb is obviously not going to fit on the top of a rocket, so something that's that big has to be folded. A consequence of this folding up is that we have to be able to do the deployment in orbit.
I feel confident that my grandchildren will be able to look up in the sky and point to a star and say, there's life. I think that's going to be a moment more profound than our Copernican moment that took Earth out of the center of the universe. It's going to put an end to cosmic loneliness. It's going to fundamentally change what we see when we look up in the night sky.